Hey guys, and welcome to the fourth episode of the Object-Oriented Programming NPC series on my channel. And starting from this episode going forward, I'm going to change how I'm making these episodes, how I'm making these videos. So from now on, you can expect the videos to be a little bit longer, but also much more in-depth, as I'm going to be actually going through them and writing the code and explaining it as I write the code versus recording me writing code and then explaining it after the fact with a voiceover. So it should be more in-depth, it should be easier to follow along. And overall, it should be also a lot easier for me to actually produce the content so I can actually finish this series. Anyway, so getting back into it, what we're going to be working on in this episode is I'm going to do some extra bonus stuff. I'm going to modify the system just a little bit. I'm not going to modify the system, but I'm going to add some type definitions for clarity, because I've learned more recently the benefits of having type definitions for everything and how it can make it much clearer, like for example, in the functions, you can define this in the base NPC new function. The char parameter is going to be a model, right? Because the character's model, right? And this is going to return a type of base NPC. We haven't defined this type yet, which is another thing we're going to do. So to get started with type definitions, so in previous episodes we set up this new function. We can create new NPCs, and it creates new NPCs using the base NPC tag right here. So it does that automatically for us. But it's a little bit difficult to know, like we have all these values that are like all these properties of NPCs, but we're going to be adding more and more, and it's just going to get more and more confusing. So in order to keep things easier to like keep up with like how the system is set up, I'm going to create some type definitions. So we're going to go over here to modules, like replicated storage modules. I'm going to add a new folder. I'm going to call this one information. I'm going to add a new module. And you could use the plugin if you wanted to. It doesn't really matter in this case. But you just do plain module, and you could call it types. But I mean, all we need is you don't need any of that. All we need is this anyway. But so in this module, we're going to define some types, which you can do by doing this. So we're going to define a type for base NPC. So what you can do is do type base NPC and then set it equal to a table. And then in this table, you can specify the properties and the types of those properties. But what we're also going to do is we're going to put an export before this, so that way we can use these types outside of this module. So that way if we require this types module from within base NPC, then we'll be able to access all the types in here. And in this module, this is where we're going to put all of our types. So every single type we create, every custom type, is going to be inside this module. So we're going to create a base NPC type. And if we reference this, we can, to make this easier, so we can like make sure we get all the properties, we're just going to copy all of this and paste it on here. We're going to have to modify this because obviously it's giving a bunch of errors. But this lets us know that we have a janitor, and the janitor it's a table. If we wanted to be more specific, we could define a type for the janitor, but I'm not going to do that because we don't really need that. It's just it's just from this module right here. And then the character is going to be, make sure you use colons instead of equal signs, because in the type definitions you use the colons to specify the type for that specific property. This is going to be a model. And then the path. I think, yeah, you could just do path. And then animate. This one's another one that I'm not going to specifically define the type, because that would take a lot of time. That would take away from actually getting the system completed. Properties. So then these are the movement properties. And this, the current path waypoints, is going to be it's going to be a table of path waypoints with a question mark at the end. And the reason we have a question mark is because this can be nil if there aren't any current path waypoints, if the NPC isn't currently moving. So we want to specify that with the question mark. And then this is going to be, so current destination. I believe this one's going to be a vector 3, but also with that question mark. Origin C-frame. And this one's just going to be a C-frame. And the loops table, we're going to define a specific type for this one. I said we weren't going to define types for like the janitor and the anime, but this one's going to be important to this specific series. So I am going to define a loop type, which I will put up here. Export type loop for the equal sign. There we go. So now this will specify that the loops is a table of loops. So, yeah. And then the move to janitor is also going to be janitor. So we're going to just put that one as an empty table as well, just so we know it's a table at the very least. Okay, so now we have that type. So then we're going to specify the loop type. We go back here and reference this. Whenever you create a new loop, it creates properties, callback, and remove callback. So those are going to be all of the properties of this type. So the properties is just going to be a table with string keys and any kind of value. You could even just put it as a plain table if you wanted to, but I'm going to specify string keys because that's how I originally intended it. If you look at the, where is it? The follow part, this uses the configure loop property, or configure loop method, and it specifies string keys and various different values. So that's going to be the properties, and then we're going to do callback, I think is what it was called. Yeah, callback. Callback is going to be a function, which in order to define functions in type definitions, you do this, where you have, this is like the parameters, like the arguments going into the function, and this is the return types. So I think the it's going to have the DT and the properties, if I remember correctly. Yeah, DT and properties. So DT is going to be of type number, and then properties are going to be a table, which is also going to be string any, just because it's going to be this table right here. And the return type is going to be none. There's not going to be any returns. Then remove callback. It's going to have the properties table. So it's going to be string keys, any type of value, going to no return values. Okay. So that's our loop types. Now we've defined that. I think that's all the types we're going to define right now. But now we need to go through this script and actually add those type definitions. So the first thing we're going to do is we're going to require this module so we can access these types. So in order to do that, I would use the g_g.require, but that actually doesn't work with type definitions. There's like a weird thing with how the system's set up, since it's not actually the require method. It doesn't like work with auto-completion and stuff. But luckily, my system's still like using this framework, the blue framework or whatever. Then you can still do regular requires if you want to, and it doesn't really break anything. It'll still work fine, just because of how module scripts work. So then we can just do specify replicated storage. And then we're going to require replicated storage, modules, information, types. So now we have that. And then NPC ID, all NPCs. We could potentially do a type definition for the module itself. That could be useful, but I might just not, because yeah, it's probably fine. So then what I'm going to do is go over here. So this is character, it's of type model. And then we're going to specify the return type is going to be base types.base NPC. And that's coming from this types module. So that's referring to this type right here. And then we can specify this as types.base NPC as well. And the nice thing about this, if we were typing this all out for the first time, we could do like NPC dot, and you can see it like already auto completes all the different properties we can specify. So we do NPC dot janitor, NPC dot character, etc. So that's another really nice thing about the type definitions. And then I believe this is already we don't even need to specify the type for this because it's already specified in this type right here. So that'll be nice too. Okay. So now the onPost simulation loop that doesn't have any returns, but this is a number. So I'll specify that. In the configure loop, this is a string. This is a table string going to any type of value. This is a function. This is also a function. I might specify this as a type though, because that we've typed that like 3 or 4 times now, so it might be nice to have that as a separate type. Export type loop properties is equal to, we can just copy this. And that way we don't have to keep typing it out over and over because it's just the same thing anyway. Okay. So then in here, we're going to replace this with types loop properties. This one is going to be number types dot loop properties. Types dot loop properties. Okay. So that's essentially the same thing as what we defined here, the callback and the remove callback. And then I'm going to change how this is set up to where it creates a new table called loop. And then it puts that table in here. So just changing the order of how this is done, so that the table is created first and then it's added to the loops table right here. That way we can actually specify the type here. Now, if you like you can see it has all the properties and everything. So then this is going to be a string, and then default raycast params. This is going to return the raycast params, so I'm going to specify that. And we already have the type definition here. It's just in a plain table. We already have type definitions here. There's no return, so that's fine. Number types.loop properties. Types.loop properties. Move to a location has no return value. It just has vector3 as the first parameter. So we can leave that one as is, and I think that's everything. So the reason we did all that is it's just going to make things easier in the long run. In order to like if you ever wanted to modify, like add new properties or change this at all, you could go in here and you could have one place you could reference for what a base NPC is supposed to look like. That way, like if you ever need to access the properties of a base NPC and stuff, like helps a lot with knowing what the properties are, what they're actually called, so you don't have to try and memorize this entire thing. Because I mean, as you go on and as you add more and more stuff, it's going to get more and more complicated. It's going to be harder to work with. But having the specific type definitions all in one place makes it a lot easier. So now we're going to get back to actually adding more stuff. The next thing we're going to add is the is some functions, some basic functionality for checking if parts are in sight, which we're going to use to check if a player is in sight. And then potentially, we're also going to set up a detection loop, which will essentially repeatedly check if there's like any players in sight, and we can use that information later when we create a aggressive NPC that'll inherit from this module. So essentially, this base NPC module, this base class, is going to be it's going to store a lot of like utility functions that we can use in other NPC classes, depending on how we need them. So like this, for example, these aren't actually going to be used in the base NPC module. They're not actually going to use these, but the other modules that inherit base NPC, they're going to be able to use these for their own custom logic. So for example, the aggressive NPC might use the follow part function to follow the nearest player. But then the base NPC module won't actually do that. Okay, so we're going to go above here. We're going to create a new function. And this function is going to essentially, it's going to take in some parameters, some arguments rather. It's going to be part, which is going to be a base part. So that's going to be like, it could be a regular part, it could be a union, it could be a mesh. And there's going to be params, which are going to be raycast params, which can also be nil. So we're going to specify that with a question mark. Include siblings as a boolean or nil. And so this is all going to return a boolean of whether or not this specific part is in sight. So this parameter here is going to be it's going to be an optional parameter if you want to, like, similar to how what we did here with the fall apart. We had the optional params, or if you want to, like, replace the default raycast params with your own raycast params, then you can, or you could just leave it as nil and it'll use the default. And this is going to be a property that I'll explain later as well. Okay, so in this function, we're going to essentially determine if a part is in sight or not, which is going to depend on a few different factors. But for now, we're going to define the character variables. So local character, which is a model, equal self.character, equal root, which is the base part, equals char, first child, humanoid, root part. Checking distance, or the radius. So the first thing we're going to do is, so NPCs are going to have, like, a limited, like, radius or distance that they can see you from. So, like, if you're, like, say the limited radius is like 50 studs, for example, if you're further than 50 studs away from the NPC, then the NPC won't be able to see you, even if you're in the line of sight. So that's the first thing we're going to check, because that's going to be, like, the least CPU intensive thing to check. So we're going to find local distance, which is the number, equals part dot position minus root dot position dot magnitude. So this is the distance between the part and the NPC's root position. The in distance equals distance is less than or equal to self dot always detect radius. And this, so first of all, this is a Boolean. It's going to be true or false. And then this is a property we're going to add. So that's going to be essentially the so this is going to be the distance within. So how I set up the system is essentially, if you're like outside of, like, the maximum radius, then the NPC won't be able to see you at all, even if you're in sight. Then if you're inside that radius but outside the minimum radius, then the NPC will only be able to see you if you're in sight, like if you're, like, in front of them. But if you're within the minimum radius, then even if you're behind them, the NPC will still be able to see you. Because realistically, if you're, like, sneaking on somebody from behind or something, they're probably going to hear your footsteps unless you're, like, really quiet, right? So I added this as, like, an extra thing. So if you get close enough to the NPC, even if you're behind them, they'll still notice you and they might come after you or run away, or depending on the NPC's logic, whatever kind of NPC it is. So then we're going to define some properties. So up here, under the follow distance margin, we're going to do base NPC dot always detect radius. That's going to be 10, so that's going to be the minimum radius I was talking about. Base NPC dot max detection radius. That's going to be 100. So anything outside of 100 studs, they won't be able to see you. Anything within 10 studs, they'll always be able to see you. Then we're also going to add some additional things. So base NPC dot detection FOV, or field of view. That's going to be 80, which is degrees from line of sight. So essentially you have this NPC and he's looking forward or whatever, right? So say this part is you, right? If you're right here, the NPC is going to see you because you're directly in front of them, right? But if you're over here, what we're going to do is we're going to calculate the angle from the line of sight that you're at. So, like, this might be like, I don't know, like maybe like a 35-degree angle. And then over here it might be like a 60-degree angle. But if you go all the way over here, this is like a 90-degree angle, right? So at some point, the NPC is not going to be able to see you anymore. And that's what this detection field of view is going to be. So we defined that as 80 degrees. So that's going to be like around here or around here where the NPC stops seeing you. So then coming back down here, so now we have this defined. So this is the in-min distance. So if it's within this distance, then the NPC is always going to detect you. So we're going to want to keep that in mind. So local in distance equals distance less than or equal to self.max detection radius. So then this is if they're within the maximum distance. And so if you're not within the maximum distance, then we already know that you're not visible, so therefore return false, and that'll end the function, and it'll also it'll essentially like let us know that the player isn't inside, or the object, the part, whatever it is. Now we could also do if in min distance, then return true end, but the main issue with this is, say like your so the NPC is like right here, and you step up like right here behind the wall, right? Maybe you enter that minimum distance, but you're behind the wall, so theoretically we wouldn't want the NPC to see you. And so we're also going to add a raycast that'll detect if there's like any parts in the way. And if there are parts in the way, it's like this wall here, then even if you're within the minimum distance, then we don't want the NPC to see you, right? So that's why we can't just return true if they're in the minimum distance. So I'm going to remove that. And then we're going to check the field of view angles. So this is going to be the direction as a vector 3 that the NPC is looking. So it's using the root.cframe.look vector, which is the forward direction of the root's cframe. And we'll call toPart. This is going to be the direction to the part in question. So this part here equals part.position minus root.position.unit. So the direction from the root to the part. Then we'll call dot. We're going to use this thing called the dot product. It's a linear algebra thing. I'm not going to explain it in this video, but if you're interested in how it works and whatnot, I recommend 3 Blue 1 Brown's videos on it. It's not on Roblox specifically, but linear algebra more generally. He has a lot of good videos on that, which I watch, which helped me to understand how the dot product works. But anyway, we're going to be using this in order to determine the angle that the player is away from the NPC's line of sight. So we're going to do dot equals root look dot toPart. And so you could do any order. Like if you did the other order like this, it'll be the same. But this will give us a number that we can use to calculate the angle. In order to get the angle itself, local angle equals math.degrees, so converting it to degrees because it's going to be using radians, math.acos dot. So the math.acos of dot is going to give us the degree in radians, which is a different form of angle measurement from the line of sight, and we turn that into degrees so it's easier to work with for us. Local n field of view. Actually, let me specify this is a number. So then n field of view is going to be a boolean. Angle less than or equal to self.detection field of view, which is what we defined up here, right? So then if not in field of view and not in min distance, then return false end. And so what we're doing here, so if they're not in the field of view and they're not in the minimum distance, then we return false. If they are in the minimum distance, we want to move on and check a raycast to make sure like they're not behind a wall or something, right? But so if they're not within the minimum distance, and then if they are within the field of view, then this won't return false, and then it will go to the next check as well. So now we're going to do checking raycast. If not params, then params equals self get default raycast params, specifying the part as the ignore part. So that way, this is just like we did in the follow part loop somewhere right here. So the reason we're specifying the part, this is for the ignore list for the get default raycast params, or the include list, sorry. And that's so we want to make sure we include this part in the search detection to like just see if that part isn't, if that we want to make sure to include that part in the raycast params, so that way we're not ignoring the part. Like if it's another NPC then how this is set up, it'll ignore all NPCs unless the part in particular is inside this include table. So then local result is going to be recast result, workspace, recast. So then the origin is going to be root.position, then to part, and then the direction is going to be what we add to the origin, so like how far away from the origin we're going to raycast to part times distance plus 5 parameters. And if not, result then return end. So essentially what's going on here, we recast, so we start from the root's position, right? We start from the NPC's root position, and then we add this to the root position for our goal destination pose, right? So then that's the direction towards the part times the distance towards the part plus an extra 5 studs. So it's going to be like, say this is the part we're looking for, right? Trying to see if this part's inside or not. It'll go to that part and it'll go an extra 5 studs just in case. So it's just the extra 5 studs is just a little extra just to make sure we're going to be able to hit the part if it's in sight. Local ray hit equals, this is going to be a boolean equals result.instance equals part or include siblings and result.instance is descendant of part.parent. So here, if the raycast result, if it hits the part itself, then we know it's obviously the raycast hit, right? But if include siblings is true, which we're going to specify later, then even if it hits a sibling part, then it'll still say that it hit it. So that's in the case of, like, say we have another NPC and it's trying to detect if this NPC is in sight. Say we're looking to hit the humanoid root part, but instead it hits the upper torso. We want to include the upper torso because it's a sibling of the humanoid root part. And then finally, if not ray hit, then return false. And then otherwise, return false end. And then otherwise, we know if it gets all the way down to this point, it hasn't gone through any of these return falses, then we know part is in sight. So then we return true. So we're going to create a new part. I'm going to call this, I'm going to remove this part to follow because I don't need that anymore. I'm going to call this site part, print cell or print NPC is part in site. I believe that's the name, right? Is part in site. Print that with the arguments workspace dot site part. We're going to just leave these as nil because we want to use the default parameters, and then we don't want to include siblings because it's just a single part. So then this should print whether or not the part is in sight in a rapid loop, so we can kind of test different positions to see if it works like we intend. So right now you can see it prints true because, I mean, it's just within the field of view range, right? If we go around far enough, you can see it turns false, right? And from behind it, it's false. If we go close enough from behind it, it goes true again. So that's good. And then another thing we want to check, if we go far enough away, it turns false, so that's good. And then I'm going to rotate this guy, make him face that way. So this is within the range, but notice now if we go behind the wall, it changes to false. But if we go over here, it's true. You can see that the raycast works. Since the wall is in the way, then now it's false again, right? And then the last thing we need to test is make sure if a player is like standing right behind them from behind a wall, you can see it's still false even though they're within the minimum range. So that's good. Seems like it's working good. It's also lagging me. Prints are very laggy when you do them rapidly. Anyway, we're going to remove this. We know it works. Okay, so now that we have the isPart in sight set up, now we can set up the detection loop. So what we did before was sort of like a haphazard loop of just, repeatedly running this and just seeing if it's in sight. Now we're going to use the detection loop instead to do that for us, but in a different way. So adding detection loop, function base NPC, detection loop, is going to be a function. And we're going to specify the parameter in the function as a table of models, so like character models, and the return type doesn't need to be anything. And then the not detected callback is going to be just an empty function, no parameters, no returns. And then lastly, the params, going to be an optional recast params. So essentially, in this function, we're going to run, this is going to be a function that we run whenever any sort of character is detected by the NPC, like any sort of characters in sight. This is going to be a function we run if there isn't any characters in sight, and this is just an optional override that we're going to send into this function, which is going to go over and replace this essentially, right? So the same thing as before. So we're going to create a new loop. So self configure loop, detection loop, and then we're going to specify detected callback equals detected callback. Don't call it though, just for the name of it. Not detected callback equals not detected callback. Also don't call that one. Recast param equals params. And then function dt number properties types.loop properties. Enter, add another function. dt, nope, this one doesn't have dt, this one just has properties, types.loop properties. If you remember, then this is the function that runs repeatedly. It's essentially ran on every heartbeat or post simulation, so that's ran every frame, and this is the function that's ran whenever you remove the detection loop. So what we're going to do in the loop itself, we're going to essentially find every character that is within sight using this is part in sight function that we created. Finding all characters, local all characters equals brackets. Sorry, so if self.detect players, then for our kind of player, which is of type player, and players get players, do local char of type model equals player.character. If not char, then continue and table.insert all characters character. And also I'm going to specify, so this, we need to define the player service. I'm going to do that up here. Local players, the service, players. And coming back down here. So this I'm going to define as a table of models, because this is going to be a table of all the character models that we find. So essentially what we're doing here, so if self-detect players, we haven't defined that yet, so I'm going to go up here. I'm going to do base NPC dot detect players. I'm going to define that as true, and then base NPC dot detect NPCs. Define that as false. So essentially, what I'm doing here is I'm defining properties for like the base NPC type of NPC for whether or not they can detect players and whether or not they can detect NPCs. And this will be useful if you want an NPC that attacks other NPCs, you would turn this on. And if you want an NPC that attacks other players, you would turn this on as well. Or if you're not doing attacking, maybe you're just having the NPC follow a player or something around, or whatever it is, then you could modify these as you need for each NPC type. These are going to be the default values. We're going to have it chase players, or we're going to have it detect players, not detect NPCs. So then coming back down here, where was it? Yeah, right here. So to explain all this, so if detect players is true, then we want to loop through every player and get their character model and add that character model to the list of character models. If it's not true, we want to ignore all the players, so we just don't include this. So then we're also going to do another one similar to this for all NPC characters. So if self.detect NPCs, then we're going to loop through all the NPCs, we're going to do if NPC equals self and continue n, because we don't want to include, so this is looping through all the NPCs, so this can be types.base NPC. We don't, however, want to include the current NPC, which is going to be self in this case, because we're running this function on the NPC object. So we don't want to include the current NPC because we don't want to have the NPC try and chase itself. That's just going to lead to errors. And if self.detect, then one last thing we're going to do, kind of similar to these two, is we're going to do base NPCs, or base NPC dot detect own kind, and set that to false as well. And essentially, so if you had detect NPCs to true, then the issue with this is that, so maybe we just added a check to where it doesn't detect the current NPC, right? But it would detect other NPCs of the same type. So if it had like another NPC right here, these two NPCs would detect each other, which maybe we don't want that to happen, right? Maybe we only want one NPC type to detect a different NPC type, but not the same NPC type. So that way, so that's why I'm adding this, so we can specify that as well. So if we have it as false, then it won't detect its own kind of NPC. So then I'm going to go back here. We're going to do if self.detect own kind equals false, and npc.npc id equals self.npc id, then continue end. So then this is going to be, it's essentially, so if we don't want to include the same type of NPC, and the NPC we're currently looping through has the same NPC ID as this NPC, then we want to skip it, essentially, using the continue right here. So then local character is a model, equals npc.character. So this is going to be the character of that specific NPC. So then do table.insert, all characters, and then the character model. Cool. So then now what we want to do, so now we have all the characters that could possibly be detected. Now we're going to loop through all those and use this as part in sight on those characters' root parts to determine which characters are actually in sight. So then what we're going to do, checking detected characters, local detected, and it's going to be the same table of models from before. And then for I, echar model, and all characters do. And I'm just saying echar, this is short for enemy character, hence the E there. It's just a terminology I like to use because it's short and simple. So we're going to find the character variables for that specific character that we're looping through. Locally root base part equals echar find first child humanoid root part. If not root, then return and locally humanoid, because it's going to be a humanoid type. Echar find first child humanoid. If not human, then return and. Okay, so then that'll essentially find the. Okay, actually we want continue end, not return end, because that'll break it. So continue is going to skip this iteration of the loop. So if we're going to look for the human or the root part and the humanoid, and if either of them don't exist, we're going to skip this character because chances are that they like died or something. So we don't want to have it lead to a bug or an error or anything. Local insight equals, it's going to be a boolean equals self is part insight root properties.raycast params true. And so what we're doing here, we're just taking this, so we have this parameter right here, it goes into the raycast params property, and then we have that in here, which we then reference. So if this is nil, then this is going to be nil, so therefore this is going to be nil. So essentially, we're just passing whatever argument is passed here all the way down into here. So if this is nil, then this is going to fire this with this being nil. So then it's going to use the default raycast params. Otherwise, it's going to override it with whatever raycast params that we want to specify. So then if in site and ehum.health is greater than 0, then table.insert detected char. So essentially what we're doing here, so we're checking, okay, so if the part is in sight according to the function we defined earlier, right, and the character's health is greater than 0, because if the character's health is less than 0, which actually what I might do, if I might just save some computing power here, if ehum.health is less than or equal to 0, then continue end. And that way we don't even have to check this here. And so if the character's health, if they're dead already, essentially, right, then we just don't run the rest of this code, and therefore we save the computing power from running this function, so we don't even run this function. Because this does a lot of stuff. It does some math, it does a raycast. It's not super intensive, but we do want to minimize as much as we can, right, to reduce lag and whatnot. So then, running callback. So this is where we're actually going to run these functions, the detected callback and the not detected callback, depending on whether or not any parts were in sight, or whether or not any characters were in sight. So if number of detected is greater than 0, then properties.detected callback detected. Else properties.detected callback with no arguments. So essentially, this is going to be passed into what I defined here as a list of character models, right? Earlier. And so if there's at least one character detected, it's going to run the detected callback. This is going to be the not detected callback. But if there aren't any characters detected, we're going to run the not detected callback, and that'll give us the flexibility to run a function based on whether or not any characters were detected. And that'll be used in like the aggressive NPC module and other NPC modules as we need it. So then in order to test this now, we can run it in here, testing site. So then NPC colon-detection loop, and then reference the arguments here. Detected, or we're going to do function with a detected model, and we do another function with no parameters, and then we don't want to specify any raycast param because we're not going to be using that in this series. We're just going to be using the default raycast params. And then so if there's any characters detected, we're going to print those characters, and if not, no characters. Okay, no characters detected. And I'm going to hit play. It spams, okay, so it's spamming that it's detecting something, but I can't really tell what. If I can like open them, but then I have to like look at, it's kind of painful, right? So if I go over here, show tables expanded by default, that'll make it easier to see. Now you can see I can actually walk around and it detects me, it stops detecting me, same as it was doing with the part and whatnot, right? If I go up here far enough, the vision is of obstruction. Its sight is obstructed by the wall, so it can't see me. But one issue with this that I actually didn't fix in my original system, but I'm going to fix in this video, is it's running really, really fast when it doesn't need to be. And that's just going to be wasted power, because realistically we only really need this to run like maybe every half a second or something, and that'll save on a lot of computing power and make it a lot more efficient. So what we're going to do in the detection loop, we're going to go up here actually, base NPC dot detection cooldown, we'll call that, is going to be half a second. And you could like do less if you wanted it to be more precise, but I'm going to do half a second because I think that's probably going to be good enough. I imagine if you like enter the NPC site for only half a second and then you leave the NPC site, you don't really want the NPC chasing you anyway, because that's like a really quick, short amount of time. So yeah, anyway. So what we're going to do is we're going to go over here, similar to what we did with the as part in sight, or no, not similar to what we did with the fall apart. We're going to add a debounce, but we're also going to add a cooldown. So we're going to do debounce equals false, cooldown. Actually, we already have the cooldown. The cooldown's up here, so we need to specify that. So we're just going to specify the debounce. And so then if properties.debounce, then return n properties.debounce equals true. Debounce. Task.delay. Self.detect cooldown, I think is what we called it. Properties.debounce equals false. I'm going to double check the name there. Detection cooldown. I might rename it to detect cooldown. No, detection cooldown's fine. Okay, so then detection cooldown. So it's going to wait for that cooldown time, and then it's going to set the debounce to false, so that'll allow it to run again. So that way it'll only run once every half a second. So now if we use our same loop from before, our same test, then we can see that now it's a lot slower, and that'll save on a lot of computing power. Now you could do faster than this if you wanted to, like maybe 1/4 of a second might be good, I'm not sure. I mean, this is honestly fine, yeah. But that should save on a lot of computing power. Okay, so we know that works good, so we're going to remove that. Okay guys, so I think that's going to be the end of this episode. It's running a little long. And as I mentioned earlier, all these episodes are going to be longer now that I'm using this new method, but they should be a lot more in-depth, and probably will get more done in each episode as well. And hopefully it should make it easier for me to actually finish this series, because it's a lot less tedious work on my end to just record it while I'm typing it, or like explain it while I'm typing it. But anyway, I hope you enjoyed this episode. I hope you like this new way of me structuring my videos. In the next episode, we're probably going to do just a little bit more preparation work on the base NPC module. We're going to add some functionality for having the NPC respawn, because right now if the NPC dies, right, then if the NPC dies, it's just going to break it. Boop. And it's not going to respawn, it's just going to kind of be in that state forever. It's not even going to delete the body parts or anything. So that's going to be an issue if you're going to have NPCs that are going to be dying, right? So we're going to add functionality for respawning, and then we're also going to add a bonus function that we'll use later in the aggressive NPC module for calculating the walk distance, for like how far apart or something is away from the NPC. So like if it's a straight path, it would just be the distance from that part to the path. Or if it's just a straight path, it would be the distance from the NPC to the part. But if it was like right here, then it would calculate the distance from here to here, and then from here to here, and then here to here, here to here, here to here, here to here, and it would get the actual distance that the NPC is going to have to walk in order to reach that part. And so that'll be useful for like determining when a player has gotten far enough away that the NPC will stop chasing that player, essentially, right? But anyway, we're gonna get to that the next episode likely, and as usual, if you want access to any of the completed files for this series or any of my other series, then you can purchase the $299 a month membership on YouTube or on Patreon. And if you want access to one-on-one tutoring of variable hours, 4 hours a month for the second highest membership, and then 8 hours a month for the highest membership, and that'll be one-on-one tutoring with me in like a voice chat, where I can help you with your projects or help you learn whatever you want, then you can also get that through either YouTube or Patreon. But either way, I hope you enjoyed the video, and I will see you next time.